Good morning, students. Today we're going to be going over section 7.4, which is going to be broken down into two parts. We're learning how to calculate the mean and standard deviation of a random variable, both for discrete and continuous distributions. Take a second right now to pause this video and to copy down this table under the pre-example heading. And what I want you to do is I want you to try and find the mean of our distribution of our x value using x and frequency. So in the past, what we would have done is we would multiply each x value by its frequency and divide by the total frequency. This is a lesson we learned from way back when on means. And we would get 350 out of 100 or 3.5 as the average. Okay, well, to calculate the mean value of a discrete random variable, which we're going to label as mu sub x, we're going to use a similar idea, but since we're given probabilities more frequently than frequency, we're going to be using a different formula, which is the sum of all x values times their probabilities. As you can see, given this example, this would look like 1 times 0.1 plus 2 times 0.15 plus 3 times 0.2 plus 4 times 0.25 plus 5 times 0.30, which would result in 0.1 plus 0.3 plus 0.6 plus 1 plus 1.5, giving us an average of 3.5. And you guys can see how this 0.1 is the same as 1 times 10 over 100. 2 times 15 over 100 is that 0.3. So we're taking what we already know about how to calculate means, but normally we're given the x value and the frequency, and we're just switching it off to saying, okay, if we're given the probability, this is how we're going to approach this problem, because for discrete random variables, most of the time, this is what our distribution looks like, a given defined random variable with its probability. It's also important to know that the mean can be called the expected value. This is actually a really important key term when it comes to discrete random variables. A lot of the time, we say expected value instead of mean. They are the same. And our expected value just shows us what we expect out of long-term results over time. So this is something really important that you want to highlight. This is how you calculate the mean value of a discrete random variable. Super important formula to remember. Okay, so we're going to move on and we're going to learn about how to calculate the variance and therefore the standard deviation of a discrete random variable. So here is your formula. The variance, remember, is the standard deviation squared. That is the sum of every x value minus the mean squared times that x value's corresponding probability. Okay, and remember, to find the standard deviation, we just take the square root of the variance. All right, so let's go ahead and do one example together. Let me just highlight really quick that this is an important formula for you. This is the variance right here. And remember, take the square root for the standard deviation, and this is for discrete random variables. Okay, X is defined as the number of courses for which a randomly selected student at a certain university is registered. So we have X and we have the probability of X. Calculate the mean and standard deviation of X above. All right, so let's do this. This is going to be kind of tight, but we can do it. The mean of the distribution is equal to each value times its probability. So 2 times 0.03 plus 3 times 0.09 plus 4 times 0.25 plus 5 times 0.4, 6 times 0.16, and 7 times 0.05. This is a little bit annoying. You can learn how to use your lists if you want to make this easier, or just plug it in your calculator, either way. And you should get the mean is 4.66. All right, that's the seemingly easy part. Now we want to find that standard deviation. So the standard deviation of x is each x value minus the mean squared times its probability. So I'm going to take 1 minus the mean, which is 4.66, square it, and multiply it times the probability, 0.02, plus x value 2 minus the mean, 4.66, square it, times its probability, 0.03, plus x value is 3 minus the mean, 4.66, square it, times its probability, 0.09. Okay, you guys get it? I'm going to pause and let you finish the rest. Don't forget to take the square root at the end of all of these summations, okay? So I'm going to pause and you guys can see if you get it correct. So you should have gotten that the mean is 4.66, obviously, and your standard deviation is 1.2. All right, so let's answer the next question. Because mu minus sigma equals, so 4.66 minus 1.2 happens to equal 3.46. The x values 1, 2, and 3 are more than 1 standard deviation below the mean. What is the probability that x is more than 1 standard deviation below its mean? Okay, we can just add those probabilities together of 1, 2, and 3. So the probability of x being more than 1 standard deviation below the mean is equal to 0.02 plus 0.03 plus 0.09, and that would be 0.14, or 14%. What x values are more than 2 standard deviations away from the mean value? What is the probability that x is more than 2 standard deviations away from its mean value? There are none. None more than 2 standard deviations, because that would be 6, so we don't have that. None, so the probability is, well, I can't say x. The probability of x being more than 2 standard deviations away from the mean is equal to 0. All right. We are moving right along, and now we're talking about how to find a mean and standard deviation for a continuous random variable. In order to do this, we need to create something called a linear combination. And a linear combination is defined as when a variable is connected to a combination, and here's like the more common term that you guys are used to, or function of other variables. So literally we're going to be kind of writing functions to help us describe a situation, and then off of that situation we can find the mean and standard deviation of a continuous random variable. Here's what a function based off of one random variable would look like. One random variable x. And here's what one would look like with 2 random variables. So we are defining one random variable or more than one random variable, and then we have an output or an outcome. How you find the mean of a linear combination, which is based off of a continuous distribution. We're going to call it mu sub y. And it's equal to, there's really no like formula. It's just what you do is based off of your linear combination, you plug all mean values, into the function or combination. And you calculate. All right, the variance of a linear combination follows a specific formula. The variance of a linear combination is equal to a sub 1 squared times sigma sub x1 squared plus a sub 2 squared times sigma sub x2 squared, plus a sub 3 squared times sigma sub x3 squared, and so on, where a is a coefficient to a particular variable, and sigma sub x1, x2, x3 is a corresponding standard deviation that you will be given for that particular variable, which we'll see below in some examples. Remember, square root for the standard deviation. Okay. Key concept here, something really important to remember, is everything we're dealing with is a random variable. All are random variables. And in this case, continuous. So for instance, if I had this equation, y equals 2x plus 3, like we saw above, we can say y is a random variable, but it's based on x. So let's really get to an example so we can understand what's going on here. Let x represent the cubic feet of a fridge. So there's our random variable x. The fridge has a base price of $300 and increases $200 with each cubic foot. The mean cubic footage of a fridge is 5 cubic feet with a standard deviation of 0.5 cubic feet. Okay, so how many variables is this linear combination based off of? And the answer is 1. 1 is defined. And that variable would be x, and that variable is the cubic feet of the fridge. And it was defined in the context. Write the linear function for the random variable x. Okay, so we can definitely do this. However, we're going to need to use another random variable called y, where y is equal to 200x plus 300, where y is the cost of a new fridge. We have to use this function of y because of the particular information that we're given about the random variable x. We can't just draw any conclusions without using this additional piece of information, which is the cost of the fridge. It's important to notice that it says over here, the mean cubic footage of a fridge is 5 cubic feet, and the standard deviation is 0.5 cubic feet. This can be noted as the mean of x is equal, this is an x, to 5, and the standard deviation of x is equal to 0.5, which is important for our formulas up here. Find mu sub y and explain what this means in context. All right, so here's how we do that. In order to find mu sub y, we take the linear combination that we are given, mu sub y, we take our linear combination that we're given, and we plug all mean values into the function or combination, and we calculate. The only mean value here I have is 5. I'm going to plug in mu sub x for x. So we're going to say 200 times 5 plus 300. is equal to 1,300. So the average price or expected value of a fridge is $1,300. All right. Question D says find the variance and standard deviation. Here's how we do that. The variance is equal to, and I'm just gonna follow the formula above, okay? Coefficient squared, so 200 squared times the corresponding standard deviation squared. My corresponding standard deviation for x is 0.5 squared. And this is equal to 40,000 times 0.25, which is 10,000. And my standard deviation is the square root of 10,000, which would be 100. One thing to note here is that we do not include constants when calculating the standard deviation, because a constant is literally constant. It is not going to influence variability in any type of situation because it's adding a constant rate. So we're not going to include constants because they do not influence variables. Do not influence variables. That's why I didn't do anything with that 300, and we never will. Okay? So here I am able to talk about a random variable y based off of one random variable x, and I can talk about that. Okay? All right. I am going to let you guys do this example on your own, so pause the video right now. Try and do A, B, C, and D, and then when you're ready, play the video to see the key. All right, you guys, so we're going to a farmer's market and collecting apples and pears in a bag to buy. The farmer's market charges by weight per pound. The average weight of an apple is 80 grams with a standard deviation of 6. So there's our information about apples. The average weight of a sugar pear is 60 grams with a standard deviation of 4. So we have two variables. By the way, this is what you could expect a question like this to be structured as. This is a very typical structure of this question. So most of the time it's kind of laid out for you in this manner. We've got two random variables here, weight of an apple and weight of the pear, and we're given those pieces of information. Our random variable W is based on the two random variables, weight of apple, weight of pear, and our weight of the bag is based off of those two things. A linear function in this case would be based off of our two random variables, 5a plus 7p equals W. To calculate the weight, remember the average weight, remember you need to take each coefficient and multiply by the corresponding mean. So you're just plugging in mean values into your linear combination and calculating out that value. We found the average weight of a bag of apples and pears is 820 grams. Calculate the variance and standard deviation for the weight of a bag of apples and pears. Okie dokie. We take the coefficient, square it, plug in the corresponding standard deviation and square it. Take the coefficient, square it, plug in the corresponding standard deviation and square that too. We get 1,684. Take the square root to find that standard deviation of 41.04. All right, so that is the end of our notes today. We will be going over this and doing some review in class on Friday. And if you have any questions, make sure you write them down and you have them ready for class. Or you can pop into office hours Thursday from 1:40 to 2:30 if you have any questions. I hope you guys have a wonderful Wednesday, and I'll see you in class on Friday. Bye! Oh.